Do you know what 0.3 is as a fraction? Do you know what 0.67 is as a fraction? Okay. What do you call the top part of a fraction? What do you call the bottom part? Okay. So when you have fractions in your empirical formula, you have to multiply by the denominator. If I multiply this by 2, what happens? 2 cancels. Left with 1. Okay, this is how you're going to get rid of your fractions if you get them in your empirical formulas. You multiply them by the denominator. So, if you get P1O 2.5, what are you going to multiply it by? Because I can't have half an oxygen.
Oh, so it's 2.5. Okay. Oh, okay.
Okay. I just did so people would know that it changed. Okay? So every element has to get multiplied by that number. Okay? So you have to have whole number ratios. So that's how you do that. You take the fraction, figure out what the fraction is on the bottom, the denominator, and that's the number you're multiplying. You won't ever have a question where you have to multiply by 2 different numbers. Okay? It'll always be the same ratio. Okay. So you have to add these 2 numbers up, subtract it from 100 to figure out how much is oxygen. So 54.4555. Thanks, Caleb. So there's the percent oxygen. So you have to assume a 100-gram sample. So you have to assume a 100-gram sample. Therefore, we've got 40.9 grams of carbon, 4.55 grams of hydrogen, and 54.55 grams of oxygen. So, using your note, we have just done step 1 out of 4. You've got the grams of each element because you've assumed a 100-gram sample. Now you have to figure out, for number 2, the moles of each element. So you divide these masses by the molar masses. We've got the number of moles of each element. Take the smallest number of those 3 numbers and divide all of your numbers by that. So which one's the smallest? So divide all of these by that number. We can't have that. You cannot round 1.3 down. So what are we going to multiply all these by? Yep. So there's your empirical formula. You have the molar mass of your empirical formula. Here's the molar mass of our empirical formula, but it says the entire compound has a molar mass of 176.12 grams per mole. So what you do is you take your molecular formula, divide it by your empirical formula, and that tells you how many times your empirical formula is in your molecular formula. So if I take 176 divided by 88, I get 2. So my molecular formula is my empirical formula times 2. 6H8O6. That's the molecular formula for our compound. That is a lot of steps. You cannot find molecular formula if they don't give you the mass. Okay? If they don't give you the molar mass of the entire compound, the only thing you can do is find the empirical formula. So, calculate your empirical formula, figure out the molar mass, divide it into the molar mass, you'll get a number, multiply that by your EMF formulas, which is a lot of work. I can show you a way to do this question with less work. Do you want me to do the same question? Okay. So you take the molar mass of the entire compound, multiply it by the percent for that element. 54.5. Now if you divide each part by the molar mass of that element, you're going to figure out the number of moles of that element in the compound. So what would I divide 72.033 by? Nope. What's the molar mass of carbon? 12.01. What do I divide the second one by? 1.01, and then the last one, 16. Divide 8 by 1. What do you get when you divide 96 by 16? Is it 6 or is it 8? So this is actually giving you your molecular formula. My molecular formula is C6H8O6. What would my empirical formula be? There you go. So this, you will always round off the carbons, hydrogens, and oxygens to the nearest whole number. You don't have to worry about a third or a half. Round those numbers off, and then that gives you molecular formula divided to get your empirical formula. So a lot of people like this one better.
Does it matter which one that we do?
No, but if a question only asks for you to figure out the empirical formula and they don't give you molar mass, you can't do this. So you have to be given this piece of information, the molar mass of your entire compound. Otherwise, you're doing it the way you did before, calculating the empirical formulas where you might get a fraction.